Good evening everyone, I'm KOURTAMAN of RAMAKRISHNAN from Bmka section 1/1, and today I'm here to present our automotive electric and electronic system assignment alongside my teammates who are SURIAVISHNU and NARVEN. So let me start by introducing our project, the Blind Spot Detection System, or BSD for short. A BSD system is part of what known as ADAS, Advanced Driver Assistance System. Its purpose is to alert drivers of vehicle or object that enters their blind spot, such as the areas that can be seen through regular rear view or side mirrors. These blind zones pose serious risk, especially during lane changes and merging maneuvers. To detect these hidden areas, BSD system used various sensors, typically radar but also ultrasonic sensors or even cameras. These sensors are usually installed near the bumper or side mirrors. They constantly monitor the adjacent lanes for any approaching vehicles. When an object enters the blind spot zone, the system activates an alert for the driver. This can be in the form of a visual cue, like a light in the side mirror, an audible alert such as a beeping sound, or even haptic feedback like a vibration in the steering wheel or seat. And this kind of feature is quite popular in newer vehicles. So next we are moving on to the problem statement. So now let's talk about the issue we are trying to solve. So in 2023 alone, Malaysia recorded over 598,000 road accidents. That's an average of 1,640 accidents per day. One of the key contributors to these accidents is the blind spot phenomenon. According to local surveys, 43% of Malaysian drivers admit to facing difficulties due to blind spot. Even more worrying, 75% believe that blind spots are a major cause of road collisions or near misses. Out of this incident, 63% were side collisions, which usually happen during lane switching. Motorcyclists are especially vulnerable. Nearly 90% of motorcyclist crashes in Malaysia involve a car as the crash partner. Studies even estimate that 37% of collision could have been avoided if vehicles were equipped with BSD system. And the problem doesn't end there. With the growing numbers of SUV and pickup trucks on the road, which have much bigger blind spots, the risk is even higher for smaller vehicles, cyclists and pedestrians. Even though drivers are taught to turn their heads and check blind spot manually, doing so in those situations, especially in fast or heavy traffic, can be dangerous in itself. So the core issue is these current mirrors and drivers' habits aren't enough to give drivers full awareness of their surroundings, and this gap is leading to avoidable accidents. So next we will move on to the project objective. So the main goal of our project is to promote the use of BSD system, particularly in Malaysia. We have three key objectives. The first one is reduce blind spot related accidents by providing real-time alerts to drivers. Second one will be improve situational awareness, help drivers make safer decisions on the road, and ultimately create a safer road environment, not just for drivers but also for motorcyclists, cyclists and pedestrians. By using affordable technology like Arduino and ultrasonic sensors, we believe that even a basic prototype can help demonstrate how BSD system can make a real difference in traffic safety. So let's move on to the system overview. So our blind spot detection system is built on the Arduino Uno platform, which is a popular microcontroller board used in prototyping and automation projects these days. So for object detection, we use two HC SR04 ultrasonic sensors. This sensor measures distance by sending out sound waves and calculating how long it takes for the echo to return. One sensor is positioned to monitor the left side and the other is to monitor the right. The system displays detection status on 16:2 LCD display. This allows the driver to clearly see whether there's an object on the left, right or both sides of the area, or if the area is clear. We connected all components using a breadboard and jumper wire with 220 ohm resistors included to protect the LCD and ensure proper current flow. The programming is done in C++, and for testing and visualization we use Tinkercad. So the system provides four types of alerts, which are object to the left, object to the right, object on both sides and area clear. These real-time alerts give drivers crucial information about the surroundings and can help prevent collisions during lane changes. So So moving on, let me now explain the flow of a blind spot detection system, the flow chart. So we begin with the start point where the system powers up. The first step is to initialize the LCD display and the ultrasonic sensors. This ensures that the hardware components are ready to operate and communicate with each other. Next, the system triggers the left ultrasonic sensor to send out a sound pulse and measure the time it takes for the echo to return. From this, it calculates the distance and any nearby object on the left side of the vehicle. It then checks is the distance less than the threshold value. If an object is detected within the threshold value, the system will display object detected on left on the LCD. If no object is detected, the display will detect as area is clear on the side. After this, the process is repeated for the right sensor as well, using the same logic to trigger the sensor, measure the distance, and compare it to the threshold. Then the system waits briefly. This delay prevents excessive sensor triggering and gives time for the display to update. Finally, the process loops continuously, allowing the system to monitor both blind spots in real time. This simple but effective logic helps alert drivers about nearby vehicle objects, especially during lane changes or merging. So I think that's it from me and will be continued by my teammate SURIAVISHNU. Thank you very much.
Thank you, KOURTAMAN. My name is SURIAVISHNU, and now I'm going to present the schematic diagram of the blind spot detection system. And first, we can see the complete diagram, which is complete circuit, which has two ultrasonic distance sensor, one Arduino, and one LCD display. If it's a real car, this both sensor will appear in the mirror side, and this LCD display will be in the car dashboard area. And now the second, we can see the both sensor are work, and it shows both object on both side. This both sensor are work in between 30 inches from the sensor to the sensing area. Above the 30 inches, yeah, it goes on clear side, clear area, both side. If it's an actual car, it will around 10 to 15 meters to detect and sensing the object. And third, we can see object on left, and we can clearly see also the LCD display shows object at 31 inches left, and same goes to the fourth as right side. It's also can see object at 30 inches right. As I earlier mentioned, above 30 inches from the sensor, it will consider as clear area. You can clearly see that LCD display also display the clear area, which both side. If the object out of the sensor area, out of the sensing region, is also considered as clear area, which we can clearly see that object in both side is out of the sensor area, and the LCD display also shows us the clear area. So this is the schematic diagram. This is how the blind spot detection sensor work. So this is the blind spot detection sensor in the Tinkercad software. And now this is the coding I built with the use of the C++ language. Now we're going to start the simulation. So as the simulation begin, we can see the object at 21 inches right. which is the site the object detect. As I earlier mentioned, after 30 inches, it's considered as clear area. We can see 30 inches on right, and then it's called as clear area. Same also out of the sensor area. We clearly see the display shows. Same also at the left. So we also clearly see the sensor area 30 inches above considered as clear area, and between 30 inches of the sensor it will detect how many inches, how many meter distance. After the region also is considered as clear area. We can see that it's so close to the sensor also is considered as clear area. So this is how the blind spot detection sensor work. Thank you.
Hello, my name is Narvin Ramesh. My metric number is B09221048. So, good evening. Today, I'd like to share about a discussion on blind spot. Okay, today, first, I'd like to discuss about cost-effective solution. So, which is we gonna use the audio, also ultrasonic sensor, which present a low cost and also affordable option for implementing basic blind spot detection. It's very low budget and easily functional. So second is effective for fundamental object detection. The system successfully detects the obstacle or object within the 30 cm range on the both side of the vehicle, which is making it more suitable for small scale of demonstration or more for a prototype. But in actual reality, it will be able to detect 5 meter with the proper parts or gadgets. So moving on ideal for prototyping and educational use. This project serves as a valuable educational tool for engineering students, especially automotive, to understand the sensor integration, real-time monitoring, and also embed system design. Limitation in real-life world application. So in real world, ultrasonic sensors are limited by short range and susceptibility to environmental interfere like rain, dirty, reflection. In real world, automotive use requires more on robust solution such as radar-based or LiDAR system for eye accuracy, longer range, and even better object differentiation. Moving on last last slide. So finally is conclusion. So in this slide conclusion, we will able to successful demonstration of core concept and also the Arduino based BST system provide a clear functional prototype that proves the integration affordable electronics for vehicle safety application, which also align with the 4.0 objective Arduino IR in automotive sector. In further future development potential, it involves switching to a radar or camera-based sensor for advanced functional. Also, AI decision making in a lane changing or avoidance on a highway, and also adding wireless module for data logging or in also a cloud-based diagnosis. for study purposes and also future improvement on the blind spot system and also contributing to safer roads. Although this is a prototype, it's highlight the significant role such as technology can play in reducing blind spot related such as accident, especially in the region with the motorcycle traffic light in Malaysia and more accurately like Klang, Kuala Lumpur and so on. That's all from me. Thank you.